All right, guys, so let's have a look at F.1. So just flick over to your notes, even if you're not up to that. And with this exercise, it won't be that we have to finish it all for homework, just that we try do as much as we can. So what we're doing here is just expanding, but we're going to expand and we're going to use index laws to help us with some expansion. So hopefully something like this, we're pretty familiar with the distributive law. I've got x to the 3 out the front, and if I'm going to expand it, it's going to multiply every term inside these brackets. So I'm going to do this in a really elongated fashion. I'm going to really spread it out, but this is sort of a 1 mark question, so you can just go straight to the answer. So what we're going to have is we're going to have x to the 3 times x to the 4, that's the first one. Then we're going to have x to the 3 times 2x. And then we're going to have x to the 3 take away, x to the 3 times 3. All right, so we're just multiplying every term. And now here we've got the same base, and so we're adding the powers, right? It becomes x to the power of 3 plus 4, that's x to the power of 7. All right. Now over here, the 2 is just going to hang out, and what we have is 2 times x to the 3 times x to the 1. So we add those powers again, 3 plus 1, that's x to the power of 4. And then we have take away 3 lots of x. So all we're doing is distributing that, and that's going to be our answer. Okay, the same rule applies for b. So I've got 3 to the x times 3 to the x. And then we have plus 3 to the x times 2. Now here, they have the same base, right? 3 and 3, they're the same base. So we're going to add the powers together. X plus x, that gives me 2 lots of x. Okay? And then over here, the correct way to write this is 2 times 3 to the x. That does not simplify. It is not 6 to the power of x. And the reason is BEDMAS, right? We think brackets, we have to perform brackets first, then exponent. We have to perform this exponent before we would multiply. So that means the simplest way we can express this is here. 2 lots of 3 to the power of x. Okay? Good. All right, on to C. Now with C, we have 3 to the power of x. Take away 3 to the power of minus x squared. So this is an important one, Sam. This is a perfect square, right? And if you want, you could do a FOIL by writing them out next to each other. The simplest way is going to be to do a perfect square. So A corresponds with 3 to the x, right? And B corresponds with 3 to the minus x. So if we have A take B squared, it becomes A squared, that should read take, sorry. A squared, take 2AB plus B squared. All right, so remember, this is A, this is B. So we're going to have 3 to the x squared, A squared, take away 2 lots of A, times b, and then plus b squared. All right? So if this is a squared, take away 2 lots of a. This is b, there goes b, and then plus b squared. All right, so I think there's 2 steps to this. The first is just to do the expansion. The second step is to process it a little bit more. So here, order of multiplication doesn't matter. The correct way to write this is 3 to the power of 2x. All right, here, these terms can multiply one another, right? They have the same base. So I'll do this one quite slowly. The 2 is just going to hang out. We have 3 and 3, so we can add the powers together. We have x take x, or x plus negative x. That's going to give me a power of 0. All right, if I have x take away x, that gives me a power of 0. I'll leave it like that for now. And then over here, we're going to have 3 to the minus 2x. Okay, so here, 3 to the 2x. And then here, 3 to the power of 0 is 1. Any number to the power of 0 is 1. That's the zero index law. So there we have this minus 2 just hanging out. And then over here, 3 to the minus 2x. Now, you might look at that and go, oh, 3 to the minus x squared, that's going to make it positive. Now, it doesn't make the power positive, but it would make the result of that positive if we were to process it. So all we're doing there is multiplying the powers together, minus 2x. All right. Very good. On to the last one. This is just a distributive law. So x to the half times 2x squared. I'm going to write it out like this. X to the half times 2x squared. And then x to the half times 3 on x. Okay, now the order of multiplication isn't going to matter. So what I'm going to do, I'm just going to rearrange them, right? I'm going to write this as 2 times x to the half times x squared. So it's the same thing, right? I've just put the 2 at the front. And then the same over here, we have x to the half times, it's going to go to the top. So we can write it like this. All right, the order of multiplication doesn't matter. I can pull that 3 out and put the x in there. Okay, so then we'll process this. We have x to the half and x to the 2. Same base, so we can add those powers. Half plus 2, 2.5, which is 5 on 2. Okay, so that number is just hanging out. 2 is just staying there. And we have x to the half times x to the 2. We add those powers together, 5 on 2. I'm not sure why I've got 2 pluses there, sorry. And then the 3 can just hang out. And we have the top power take away the bottom power. Always the top power take the bottom power. They're the same base, right? X to the half on x to the 1. If there's no power written there, it's a 1, right? X to the half take 1. That's going to be minus half. And that is the solution.
Seriously, I don't get why can't we
Simplify that to 6 to the power of x. Well, let's just check.
Because x can be positive or negative, right?
Yeah, so let's see if it works. Let's go, let x equal 1. Okay? So we have 2 times 3 to the 1. That's going to be 2 times 3, which is 6. And over here, 6 to the 1. All right, let's check. What about if x equals 2? Well, 2 times 3 squared, which would be 2 times
18.
9, 18. And over here, 6 to the power of 2, 36. So it doesn't work for all values of x. So yeah. So that's one way you can check if they're equal is just start putting numbers in and see if it works. Because you're right, it does work for 1, but just because it works for 1 doesn't mean it works for all.
Okay, I've never seen that because we don't work with the upper thing like x or something.
Oh, the powers, yeah, as a power of x, yeah.
Okay.
Yeah, but if that wasn't a power, if it was a product, you'd be absolutely correct. They're the same. Yeah. All right, so yeah, hopefully the expansion skill makes a bit of sense. Just do as many as you can tonight. If you finish it, fantastic. So see how we go. Got 8 minutes left. So